Today I'm going to do chapter 14.2, the chain rule. Okay, we look at this function here, y equals to x plus 2 to the power of 5. Normally, if you want to expand this, what you need to do is you probably have to use the binomial theorem. Okay, then you expand everything, then you differentiate y with respect to x. Today I'm just going to show you the method, okay, of the chain rule and how I can use the chain rule to differentiate such a function. So without much further ado, I'll just dive right into exercise 14.2, okay, question 1a, which is given there. To differentiate y equals to x plus 2 to the power of 5. Now first and foremost, we are differentiating y with respect to x, so we're differentiating y with respect to x, and then down here for the chain rule, okay, same thing as before, we bring down the power 5x plus 2, okay, then 5 minus 1 is 4. Okay, the extra step that you must do here is this: once you have brought down the power minus 1, you have to differentiate what's inside the bracket. You differentiate x, you get 1, you differentiate a number, you get nothing, so you get multiplied by 1. So the first differential of y equals to x plus 2 to the power of 5 is 5 times x plus 2 to the power of 4. That is question 1a. Okay, now next one that we're going to do is 2d. Okay, 2d works like this. I have to differentiate with respect to x 6 divided by 2 minus x squared. Alright, first thing I do, I rearrange my expression to get 6 minus x to the power of negative 2. So I've expressed it in negative index form. Okay, now when I begin differentiating negative 2, same thing I bring down, so it's 6 times negative 2. Then I get 2 minus x. Okay, minus 2, I'll have to minus 1 to get negative 3. Here's where don't forget to differentiate the bracket. Okay, what is inside the bracket is 2 you differentiate, you get 0. Negative x, you differentiate, you get negative 1. So in the end, I simplify. 6 times negative 2 times negative 1 is positive 12 times 2x to the power of negative 3. If you want to simplify it, you can write it as 12 to the power of 2 minus x cubed. And we get something is differentiated. We have expressed it in positive index form. I'll just do one last question with you, and then that's it for this portion, because this is just a method, nothing much here. I'll do 3d. Okay, 3d is to differentiate with respect to x. Square root of x squared minus x plus 1. First, I write it in a form that's easy for me to differentiate. I write x squared minus x plus 1 to the power of half. First step I do, okay, when you differentiate, bring down the half as per normal. You get x squared minus x plus 1. Okay, don't forget to minus 1 here. Half minus 1 is negative half. Then, next part, we have to differentiate the brackets. X squared minus x plus 1 gives me 2x minus 1. So, if I simplify everything, I'll get 2x minus 1, okay, over 2 times x squared minus x plus 1 to the power of half. Alright, from here, what we do next is this. If you want to write it more nicely, okay, this power of half can be written as 2x minus 1 divided by 2 times square root of x squared minus x plus 1. And that is all the examples that I'll be giving from chapter 14.2. The rest will be practiced in class.